Welcome back to Inorganic TUTOR'S Institute. In today's lecture, we are basically going to look at about 20 multiple vector algebra and differential equation problems that will enhance our understanding and our preparation towards our end of term examination. Okay, so this is basically your quiz one, okay? And we are going to take each problem, explain it into details so that if there is any changes, we can go ahead and do that problem as well. So the first problem is we want to find the scalars, okay, P and Q, such that C is equal to PA plus QB. Now, we have been given the position vector for A, B, and C. So what we have to do is to substitute those position vectors into the equation given. Okay, then we can find the scalars P and Q. Okay, so basically whenever you have this kind of problem, all right, you have been given position vectors and you have been given a certain equation, right? And the equation involves scalars, right? And you want to find the scalars, you just have to substitute the position vectors into the equation. Then you have, if it is two unknowns or two scalars, then you have two systems of equation. Then you solve it simultaneously, either by elimination or by substitution. Then you are good to go. So from here, we are going to substitute position vector A, of which is equal to 1, comma, -4. This you have here, this is called the angle bracket form, okay? Or you can also write it as I minus 4j. This is the angle bracket form, and this is the position vector form, all right? And the B is -2, 6. So this is the same as -2i plus 6j. And also the C is equal to -2, 3. So this means that our C is also -2i plus 3j. So if you don't see this, is the same as this. If you don't see this, it's the same as this. This symbol is angle bracket form. So this, we use this when we are dealing in space, right? Because when you have ijk and it continues in that way, you cannot be using ijk. You have to use the angle bracket form. So in that case, you just have to state the scalars. So maybe 1, 2, 3. Then you bring your angle bracket form. So this symbolizes that this is I component, this is J component, this is K component. So if you don't see the angle bracket form, it's the same as I. If you don't see this, it's the same as the J. Okay, so we are going to handle the problem step by step. Okay, so in here, this is our equation. Okay, so we are going to substitute this into this. So we have C equals PA plus QB. And our C here is -2i plus 3j. And that is equal to P into brackets. Our A is I minus 4j, right? Plus Q into brackets B. And our B here is -2i plus 6j, right? So we have to expand this expand this, then we know what to do. So we are going to have minus 2i plus 3j equals pi minus 4j plus this, and this will give us minus 2qi. This and this will give us plus 6qj, right? So we have to combine the common terms, right? So we have pi here and we have minus 2qi. So we have to combine this and this, then we combine this and that. Okay, so we have minus 2i plus 3j equals this, and this becomes p minus 2q or I. Then this and this becomes minus 4 minus 4p, then plus 6qg, right? So this and this in one bracket, this and this also in one bracket. So we can see that this is I component, this is I component, this is j component, this is j component. So we can compare them component wise, right? So comparing them component wise, we are going to have this minus 2i equals this part, p minus 2q or I, right? So we simplify this and we have minus 2 equals p minus 2q. And this becomes equation 1. Then we have this 3j equals minus 4p plus 6q, right? So this as well becomes equation 2. Now, we solve equation 1 and equation 2 simultaneously, and then we obtain the values of p and q. Okay, so in here we either use elimination or substitution. So we can easily use elimination and move away, right? So with equation 1, when you multiply equation 1 by 2, equation 1 by 4, we are going to have 4 here, so that this and this, when we add, the p will go. So multiplying equation 1 by 4, we have 4 times 2 is minus 8, right? Minus 2 is here, right? So minus 8 equals 4p minus 8q, right? So we name this equation 3. So add equation 3 and equation 2, right? So in doing so, we are going to have minus 8 equals 4p minus 8q plus 3 equals minus 4p plus 6q, right? So when we add this and this, we are going to have minus 5, and that is equal to, when we add 4p and minus 4p, you're going to have 0, right? And then when we add minus 8q and 6q, we are going to have minus 2q. So we have minus 2q. Okay, so when we divide here by minus 2, we have our q to be equal to 5 on 2, right? So we have obtained the value of q to be 5 on 2. That means that when we substitute the value of q, which is 5 on 2, into either equation 3 or equation 2, we can have the value of P, right? So let's come here. So we come here. So let's consider this as equation 4. So putting equation 4 into, let's say, which one should we consider? Let's say equation 2. Then we are going to have 3 equals minus 4p plus 6 into, our Q now is 5 on 2, right? So we put that there. So we're going to have 3 equals minus 4p plus 6, 5, 30 over 2, right? So we have 3 equals minus 4p plus 30 divided by 2 is 1, 5, 15, right? Now we need p. So we send this here and bring this here. So we're going to have 4p equals 15 minus 3, right? So we have 15 minus 3. So 4p is equal to 15 minus 3 is 12, right? So we have our p to be 3. Yep. So our p will be equal to 3. So we can conclude that hence the scalars of P and Q are 3 and 5 on 2. Very simple, right? Very, very simple. So now we have been able to obtain the values of what? P and Q as 3 and 5 on 2 respectively. That is so cheap, right? So let's move on to question number 2. This is very simple. Whenever you have a problem of this nature, one thing you have to know is that this symbol is an angle bracket notation, right? So we use this when we have higher dimensions, right? Um, we are using the I, J, and K because we are not in higher dimension. But once we extend from the IJK, we can't be using IJK again. We have to use the angle bracket form so that we just take the scalars, then we put the angle bracket there. Very simple. So if you don't see the IJK, it's the same as this. Put this, that is all. So the solution to question number 1 is the value of P is 3 and the value of Q is 5 on 2. Now let's move on to question number 2, of which we are going to make it very simple as well to make everything so cheap. Okay, let's. So with question number 2, we want to find the equation of a particular line, right? Given that C is equal to 1, neg 2, neg 1, and B is equal to neg 3, 4, and 2, right? And the line passes through a point C. So this point C, the line passes through that point C and is parallel to that vector B, right? So if you have a line that is passing through a particular line, so we call that particular line C, okay? And it is parallel to another vector, right? So that vector here is B. Then if you want to find the equation of that particular line, then what you have to do is that first, we have a formula for it, okay? So first of all, you have to know that if a particular line, okay, passes through a point, okay, and is parallel to a vector, say B, then your equation of that particular line will be given as R of t equals R naught plus t times d. Now, what does this mean? This we see here, the R naught is basically the point C. The point C is your R naught, and the D is the vector that is parallel to the point C. Okay, so R naught is equal to the point C, 1, neg 2, neg 1, and D is the vector, okay, the vector that is parallel to the point C. Okay, so that is the B, which is neg 3, 4, 2. Okay, so if you are interested in finding the equation, then you just have to substitute these two coordinates into the equation. This is the formula, right? So that you can obtain the equation of that particular line. Now, let's go ahead with that. So that will be equal to 1 neg 2 neg 1 plus t into b is neg 3, 4, 2, right? So this that we see here from earlier notice from question 1, I told you that this is basically telling you that the I component, this is the j component, and this is the k component. So the same thing applies here. So we are going to have R of t equals 1, comma, neg 2, comma, neg 1, plus, we expand this bracket. So we're going to have neg 3t, 4t, and 2t. Okay? Now, we have this and this, right? We want to find the equation of this particular line. So once we have this, this becomes a direction vector, and this is the initial points. Okay, so if you want to get the equation of the line, then you have to add the initial points to the direction vector. And the initial points, each of the points here have a component. This is the I component, this is the j, and this is the k. Same thing applies to the initial points. This is the I component, this is the j, and this is the k. So if you want to add these two, then you have to consider them component-wise. So we have R of t equals this, and this becomes 1 minus 3t. Then this and this becomes 4t minus 2. This and this becomes 2t minus 1. Okay, so this becomes our position vector for the equation of the line for this particular problem. So this becomes our position vector. Now we are interested in the equation of the line. So what do? We have to, we know that this is the s component, which is basically the I, okay? This is the j, which is the y, and this is the k, which is the z. So we go up here, then we say that let x equals the I component, which is 1 minus 3t, and then y should be equal to the second component, which is 4t minus 2, and z should be equal to 2t minus 1, right? So here, what we have to do is that we have to make sure that we have common ratio. Okay, so we are going to make t the subject in let's consider this as equation 1, this equation 2, and this equation 3. So we are going to make t the subject here, make t the subject here, and that of this also t the subject. So from equation 1, we can say that x minus 1 is equal to minus 3t, right? So if you need t, then we can say that we have 1 minus x over 3, right? So it just divided through by minus 3, okay? And that turns to this. Okay, so this becomes our first component. Okay, so we have this. Now let's come to this. Y equals 4t minus 2. We need t. So we send the 2 here. So y plus 2 equals 4t. Divide here by 4. Divide here by 4. So this means that our t will be equal to y plus 2 divided by 4. Okay? So we have t equals y plus 2 divided by 4. Okay. We also have this. And then we have z equals 2t minus 1, right? And we need t. So we have z plus 1 equals 2t. So making t the subject, then we are going to have t equals z plus 1 divided by 2. Very simple, right? So here, this is our t as well by making it the subject in equation 3. So when we made t the subject in equation 1, we had this. When we made t the subject in equation 2, we had this. And when we made t the subject in equation 3, we had this. Now, we can see that this, and that have common ratio. Means that we have t equals this, we have t equals that, and we have t equals that. So if you have Einstein equals 1, who else? Elias equals 1, and then you have Hessian, right? Also equals 1, then means that you can equate them, right? So what I'm trying to say is that if you have A equals 2, B equals 2, C equals 2, then means that A is equal to B, C is equal to B, and that of B is also equal to C. So we are going to apply the same knowledge here to equate these things. Okay, so when we equate this to that, then we have 1 minus x over 3 equals y plus 2 over 4 equals z plus 1 over 2. Okay, so this is the symmetric form. This is the symmetric form. Okay, so we come up here and present it well to have 1 minus x divided by 3 equals y plus 2 divided by 4 equals z plus 1 divided by 2. So this becomes our equation of the line, in the symmetric form. So that is question number 2. Now let's move on to question number 3. Okay, so with question number 3, what you want to do is that you want to find the equation of the plane. Okay, you want to find the equation of the plane containing these 2 points. Okay, these 3 points. First point is x of 4, 3, neg 1. Second point is I of neg 3, 1, 1. And R of 2, 1, neg 8. Okay, so first of all, if you have 3 points, all right, if you have points and you want to find equation of that particular plane, okay, then first, what you have to do is that you have to locate 2 points, right? You have to find 2 vectors on the plane, right? So first, you have to find 2 vectors on the plane. Okay, so 1 or A, find 2 vectors on the plane. Okay, so in doing that, then it means that with regards to this point that we have here, we are going to consider, let's say, SI and then let's say SR. Okay, that is 2 vectors that we are considering here. You can also consider SI and consider IR. It's all good. But I'm considering SI and SR. Okay, so the 2 vectors that we are considering here are SI and SR. Right? So it means that we have to find position vector SI, of which is equal to I minus S. Right? So SI will be equal to I is this, right? So we have neg 3, 1, 1 minus X is 4, 3, neg 1, right? So we have SI to be equal to this minus this, right? So you're going to have minus 7, okay? So please, whenever you are doing vectors, make sure you talk about it in component wise. You see, this is I component, this is J component, this is K component. Same thing applies to this. This is I, J, and K. So if you are doing any subtraction or whatever you are doing, you have to do it component wise. So I component is minus 3 and the I component here is 4. So we subtract this from this and we have minus 7. 1 minus 3 becomes minus 2. 1 minus minus 1 becomes 2. Right? So this is our position vector SI. So we have to also find SR. So we have SR to be equal to R minus S. Right? So we have SR equals R here is 2, 1, neg 8, and our S is 4, 3, neg 1, right? So we do that subtraction, this minus this becomes minus 2, this minus this becomes minus 2, this minus this becomes minus 7. Okay, so our 2 vectors, the 2 vectors are Si, which is equal to neg 7, neg 2, and 2. And SR is equal to minus 2, minus 7, and minus 2, minus 2, and minus 7. Okay, so once we are done with that, then we have to find a normal to the plane. A normal to the plane. So we let n equals, n is the normal, okay? N equals Si times SR, right? So that is how we find the normal. That is why we already, we first of all obtain the two vectors. So once you have the two vectors, then you find their normal. Okay, so here we know that this we are going to use the matrix, right? So that will be equal to I, J, K. And we have our S, I here to be minus 7, minus 2, and 2. And the SR is minus 2, minus 2, minus 7. Right, so our normal will be equal to I into minus 2, minus 2, 2 minus 7, minus J into minus 7, minus 2, 2 minus 7, plus K into minus 7, minus 2, minus 2, minus 2. Right? So our normal will be equal to, this becomes 14, right? Minus, this and this becomes minus 4, but on the up diagonal, it is minus, right? So it becomes plus 4, or I. Then this and this becomes 49, right? So we have minus j into 49. Then this and this as well becomes plus 4, right? Okay, plus k into this and this becomes 14. So we have 14. This and this becomes 4. Then the minus makes it minus, right? So we have minus 4. Okay, so we have our normal to be equal to this and this becomes 18. So 18i minus j into this and this becomes 53. So we have 53 plus this and this is positive 10. So plus 10k. Okay, so this will be equal to 18i minus 53j plus 10k. Okay, so this is our normal to the plane. Now, what are we going to use this for? It's very simple. The formula for equation of a plane is, the formula for equation of a plane is a into x minus x naught plus b into y minus y naught plus c into z minus z naught. And that is equal to d, right? You know that the d part is equal to a constant, which is 0. Okay, the d part is equal to a constant of which is equal to 0. So we are going to substitute the values in here. This we obtain here is going to help us here. because the A we see here is the coefficient of I. The B we see here is the coefficient of J. And the C we see here is the coefficient of what? K. So our A is 18, our B is minus 53, and our C is 10. Now, what is going to be our point? You see, we have x minus s naught, meaning that the initial point for s is what? S naught. And that is the first point, right? Now, take note. Once you have the two vectors correctly and you go ahead to find the normal and you have it correctly, then you are at the liberty to pick any point to become your initial point. Take it again. Once you obtain the two vectors correctly and you go ahead to find the normal to the plane and you have it correctly, then any of the points that you pick here will give you the correct equation of the plane. Okay, so it doesn't mean that you have to pick S or you pick I or R before you get the right equation of the plane. Once this information is correct, any of the points you pick becomes correct. Now, I'm going to consider S. So, considering S, which is 4, 3, neg 1, that means that our S naught will be 4, our Y naught will be 3, and our Z naught will be negative 1. Right? So we are just going to substitute these points into the formula and we are good to go. Very simple, right? So in here, our A is 18 into x minus x naught is 4, and our B is minus 53. Our Y minus y naught is 3 plus C. Our C is 10 into Z minus Z naught is minus 1, so it becomes positive 1. And that is equal to 0. Okay, so we're going to have 18x minus 18 times 4 is basically 72, right? Minus 53y plus 53 times 3 is basically 159. 159 plus 10z plus 10z plus 10, and that is equal to 0. So we are going to have 18x minus 53y plus 10z. Then we add the constant minus 72 plus 159 plus 10 basically becomes plus 97 equals 0. Okay, so we're going to have our equation of the plane plus 97 equals 0. So this becomes our equation of the plane. Very simple, right? So let me take it again. If you have 3 points, okay? If you have an equation that contains 3 points and you want to find the equation of that particular plane, then first of all, find two vectors. Find two vectors. Don't forget, if you are talking about vectors, then order really matters. So if you are choosing your vectors, make sure that you know S comes before I, right? Right? S comes before I. So if you are choosing your vector, say that Si and then Sr. Or IR. It's all good. But don't choose IS. That is a wrong vector. We are talking about vectors. Order is very important. So don't bother yourself. Just choose Si and Sr. You are good to go. Allow to choose first and second, first and last. That is my vectors. That is what I always choose. So once you have your two vectors, find the position vector. Okay? So if you take Si and Sr, find the position vector of these two vectors. So once you have them, find the normal between these two vectors. Okay, you find the normal between these two vectors, and you know that if you have two vectors and want to find the normal between them, that means that you have to use the cross product, right? You have to use the cross, and that is the matrix. Okay, so once you use the matrix and you find the normal, then you are at the liberty to choose any of the points when you are doing your, or when you are finding your equation of the plane, and that becomes very simple. So to this particular question, our equation of the plane is 18x minus 53y plus 10z plus 97 equals 0. And that is our equation of the plane to this particular problem. Now let's move on to question number 4. So with question number 4, we are given 3 points. Okay, we have been given 3 points, and we want to find the area of the parallelogram that will be formed given these 3 points. Okay, so first of all, if you have points, okay, especially 3 points, and you want to find the area of the parallelogram, then first find, you just need, the formula is magnitude of position vector AB cross position vector AC. So what you have to find is your position vectors first. So step 1, state your formula. So let's say that you are letting B equals AB, position vector AB cross position vector AC, right? So this is what you need, then you are good to go. So first of all, find position vector AB, then find position vector AC. When you are done, then you find the cross products. Okay, so first of all, our position vector AB will be equal to B minus A, right? And our B here is this. So position vector AB will be equal to 1, neg 1, 2 minus A, which is 2, 3, 2, neg 3, and 1. Okay, so our position vector AB will be equal to 1 minus 2 becomes minus 1. Minus 1 minus minus 3 becomes plus 2, right? So we have 2. Then 2 minus 1 becomes positive 1. Okay, so the position vector for AB is basically negative 1, 2, and 1. Okay, so we have to also find position vector AC. So position vector AC is equal to C minus A, right? Position vector C minus position vector A. And our position vector C is 1, 2, 3 minus that of A is 2, negative 3, 1, right? So we're going to have this to be equal to this minus this becomes negative 1. So we have negative 1. This minus this becomes plus 5, right? So we have 5. Then this minus this. 3 minus 3 becomes 3 plus, right? So we have 6. So we have position vector AC to be this. Now, once we have the position vector AB and we have position vector AC, then what we need is no, this minus this is minus 1. This minus this is 5. This minus this is 2 instead, right? So 3 minus 2, 3 minus 1 is 2. Okay, so the position vector for AC is -1, 5, and 2. Now, once we are done finding the position vector AB and that of position vector AC, then it means we have to find the cross product because the formula is this. So, cross product of AB and AC, right? So, we're going to have IJK. And our AB is -1, 2, and 1. And our AC is -1, 5, 2. Right? So let's do this. 2, 5, 1, 2 minus J into -1, -1, 1, 2 plus K into -1, -1, 2, 5. Now, we are going to have I into this and this will give us 4 minus this and this will give us -4, -5, right? So we have -5 minus J into this and this will give us -2. This and this will give us +1. This and this will give us -5. This and this will give us +2. So we have +2. Right, so let's simplify that. So we're going to have I into 4 minus 5, -1, minus J into this and this will give us -1, plus K into this and this will give us -3. Right, so we are getting our cross product of AB and AC. Right, so once we have that, so we're going to say that our cross product of AB and AC will be equal to -I plus J minus 3K. Right, so this is our cross product for A and C. Now, what do we need? We have to take the magnitude of this cross product. So our B will be equal to magnitude of this, right? So we're going to have magnitude of this position vector, and that will be -1. squared plus 1 squared plus negative 3 squared. And that will be equal to negative 1 squared is positive 1 plus 1 plus 9. That is negative 3 squared is positive 9. So we are going to have square root of 1 plus 1 is 2 plus 9. So we're going to have our area of the parallelogram to be square root of 11. So that is the process. So the area of the parallelogram is square root of 11. Very, very simple, right? So what I want you to know is that if you have 3 points and you want to find area of the parallelogram, then first state your formula. So area of a particular of a parallelogram of a given point is given as magnitude of the position vector cross the other position vector. Then you find, once you know that, just find the position vector of the first part, position vector of the second part, take the cross. You know the cross, you're going to use the matrices. So once you have the cross of the first position vector and the second position vector, the result that you obtain for these two the cross products, find magnitude of it. Once you have the magnitude, that result becomes the area of the parallelogram. So interesting, right? Okay, so let's move on to question number 4. Yeah, we are going to question number 5. So interesting, right? So interesting, right? So let's move on to question number 5. Okay, so with question number 5, we want to find the point P, right? Where the line s equals 8 over 3 plus 2t, y equals negative 2t, and z equals 1 plus t, okay, intersects the plane 3x plus 2y plus 6z equals 6. Okay, so if you have a plane, right, that have points, right, that have points with some unknowns, and it's that points are intersecting the plane, and you want to find the point, the exact point, then first what you have to do is that you have to substitute the point, including the unknowns, into the equation of the plane. Then you notice that you are going to have an equation that involves only one scalar, right? Only one unknown. So once you do that, you'll be able to find that unknown. Then after, you go and substitute into the points to find the exact point for each of the components. So with this problem, we have x equals this, y equals that, z equals that, and we have this. So it means that we can substitute x, the point for x, into this equation. Substitute y equals this into this, z equals this into that, so that we have an equation involving only one variable, which is going to be the t. So putting x equals 8 over 3 plus 2t, y equals minus 2t, and z equals 1 plus t into the equation of the plane. We have 3 into x is 8 over 3 plus 2t plus 2 into y is minus 2t plus z is 1 plus t, and that is equal to 6, right? So we simplify this, find the value of t, then after we substitute into each of the points to find the exact value for each point. So we come here, we have 3 into 8 over 3 plus 2t plus 2 into negative 2t plus 6 into 1 plus t equals 6, right? So let's expand each of the brackets so that we simplify. So this, when you expand this, we're going to have 3 times 8 over 3 plus 2 times 3 is 6t minus 4t. This and this will give us plus 6. This and this will give us plus 6t. And that is equal to 6, right? So we can see that this cancels this. So we have 8 plus 6t minus 4t plus 6 plus 6t equals 6, right? So we add all the constant. So this and this will give us minus 6t minus 4t becomes 2t plus 6t. Then 6 plus 8 becomes 14, right? So plus 14 equals 6. 2 plus 6 is 8t. So basically, we are going to have 8t plus 14 equals 6. So we have 8t equals 6 minus 14, right? So we have 8t equals 6 minus 14 is basically minus 8, right? So we have minus 8. So it means that our t is minus 1, okay? So once we have the value of t to be minus 1, then we go ahead to substitute into each of the points to find the exact point for the equation of the line. So here we say that our x equals 8 over 3 plus 2 into negative 1, because our t is negative 1. So we're going to have our x to be equal to 8 over 3 plus negative 2. So 8 over 3 minus 2, right? So we are going to have x to be equal to x to be equal to 2 over 3, right? So we have the value of x to be 2 over 3. Now, we have the value of x. So we have to go and substitute t equals negative 1 as well into y equals negative 2t. So we have y equals negative 2 into negative 1. So y is what? Positive 2. And then z equals 1 plus t, and t is negative 1. So 1 minus 1, and that is equal to 0. So that means that our value of z is 0, right? So it's very simple, okay? Just have to relax for the question and analyze the question, then you go ahead to solve. So we can say that our point, the point P is giving us our S is what? 2 on 3. our y is 2 and our z is 0. So this becomes the point where the line s equals this, y equals this, z equals this, intersect the plane 3x plus 2y plus 6z equals 6. So this becomes our point. 2 over 3, comma 2, comma 0. Very interesting, right? Very, very interesting. Now let's move on to question number 6. Okay, so with question number 3, we have been given 2 lines, okay? We have been given 2 lines, and these 2 lines intersect at a particular point, which is 1, neg 1, and 2. Okay, now we want to find the equation of the plane that containing these 2 lines. This is line 1 and this is line 2. Now, how do we do this? Now, we know that this equation or this line x minus 4 equals y plus 2, y plus 1 over 2 equals z minus 3 over 2 is our first line, right? This is basically over 1, okay? This is basically over 1. Now, let me tell you some secret. You may not know it in this vector course, but when you come to advanced, you will understand. When you have a line and you want to know the direction vector of that particular line, then your direction vector is this, this, and that. So this is the I, this is D, this is K. Okay? And this here, okay, becomes your point, the initial point. This becomes your initial point, this becomes your initial point. So your direction vector here is direction vector for line 1 is 1, 2, 2, right? So we call that D1, okay? And if we are not interested in this point over here, but I want to tell you that if you are interested in the initial point is the point over here. So this is when you equate this to 0, then you have your first coordinate. When you equate this to 0, you have your second coordinate or your second component. And then when you equate this to 0, you have your third coordinate. And that becomes your initial point. And this, the denominator, is your direction vector. Okay, so to this line, our direction vector is this. Now let's go to the second line. The second line is x minus 5 over 2 equals y minus 1 over 4 equals z plus 2 over 3. So as we learned here, the same thing applies here. So the direction vector over here, the direction vector is, let's call that 2, d2 equals 2, 4, 3. Right? Now, we have the direction vector of these 2 lines. What do we need again? We have to find the normal to these 2 direction vectors. And you know, if you want to find the normal of these 2 direction vectors, then you have to apply the cross product, right? So finding the cross product, so we are interested in the normal, right? So n equals I, J, K. right? So this is our first direction vector, and that is 1, 2, 2, right? And the second one is 2, 4, 3. So we're going to have I into 2, 4, 2, 3 minus j into 1, 2, 2, 3 plus k into 1, 2, 2, 4. So our normal vector today to these two direction vectors will be equal to I into this, and this will give us 6. This and this will give us minus 8, minus j into this, and this will give us 3. This and this will give us minus 4, plus k into this, and this will give us 4, minus this, and this will give us 4, right? So we then we can say that our normal vector will be equal to negative 2i minus j into negative 1 plus k into 0, right? So we have our normal vector to be equal to negative 2i plus j plus 0. Okay, so this is our normal vector. Now, we know that if you want to find the equation of a particular plane, once you have your normal vector, then you just need your point, your initial point, right? And in here, our initial point is the point at which it intersects the two lines, right? Becomes our intersection. So our intersection is our initial point. And you know that if you want to find equation of a plane, then you have x a into x minus x naught plus b into y minus y naught plus c into z minus z naught all equals what? 0. And from the equation of the our normal vector, we know that our a is the coefficient of I, which is minus 2. Our b is the coefficient of j, which is 1. And our c is the coefficient of k, which is what? 0. So we have c to be 0. Now, our s naught is the point. Y naught is minus 1. And z naught is what? 2. So we're going to substitute those points inside the formula. Then we get our equation of the plane. So we have minus 2 into x minus 1 plus b is 1 minus minus becomes positive, right? Plus 0 into z minus 2, right? So we have minus 2 into x minus 1 plus 1 into y plus 1 plus 0 equals what? 0. So our equation of the plane becomes minus 2x plus 2 plus y plus 1 equals 0. Okay, so we have minus 2x plus y plus 3 equals 0. Okay, so basically this equation becomes our equation of the plane, but we can multiply through by we have minus 2x plus y plus 3 equals 0, but we can multiply through by negative 5, right? So when we do that, we are going to have negative into minus 2x plus y plus 3 equals 0, right? So this and this will give us 10x. This and this will give us minus 5y. This and this will give us minus 15 equals 0. So interesting, right? So this becomes our equation of the plane, given these two lines and their intersection. So let me go over again. If you have two lines, two symmetric lines, right? And you want to find the equation of the plane of these two symmetric lines, and these two symmetric lines have an intersection that was given, right? If you don't have the intersection, you cannot find the equation of the plane. You need further information to find that. So you have these two lines, right? And you want to find the equation of the plane. The first line, the denominators, right? The denominators become the direction vector to the first line, right? And the second line, the denominators as well becomes the direction vector to the second line. So once you have these two direction vectors, find their cross product. Once you have the cross product, you know that the coefficient of I is your A, your coefficient of B, your coefficient of J is your B, and the coefficient of K is your C. So once you have this info, then you know that the intersection is your initial point. The first part is your S naught, second coordinate is your Y naught, and Z naught is your last component. That is going to be substitution. Then you are good to go. Very interesting, right? So let's move on to question number 7. So with question number 7, we want to determine, or we want to check that does any of the options that I'm going to mention, right? The line lies on the plane. Option B, the line is parallel to the plane. Option C, the line is perpendicular to the plane. And option D, the line is neither parallel nor perpendicular to the plane. Given these informations, right? So now we have these informations. Consider this the line given by the parametric equations. S equals 1 minus 2t and y equals 2 plus 5t and z equals negative 3t. And the plane given by the equation 2x plus y minus z equals 8. And we want to check that which of these information that I mentioned earlier will be true given this info. Now, what we have to do first with regards to this particular problem is we have to get the direction vector of the line, right? So we have to get the direction vector, and from the parametric equation that we have been given, the direction vector from this parametric equation given x equals 1 minus 2t, y equals 2 plus 5t, and z equals negative 3t. Our direction vector are the coefficients of the scalars, right? So our direction vector here, d, will be equal to negative 2, 5, and negative 3. These are the direction vectors in this parametric equation. So take note. If you have a parametric equation and you want to know the direction vector, then the direction vectors are the coefficient of the scalars. So in here, the scalars are t, 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 right? So 1 minus 2t, the direction vector here is minus 2. 5, 5t plus 2, the direction vector here is 5. Minus 3t, the direction vector here is minus 3. So when you have a parametric equation, the direction vector is the coefficient of the scalars. And the question that we solved earlier, you saw that the direction vectors are the denominators, right? That one, it was arranged in the symmetric form. So if it is arranged in the symmetric form, then the direction vector is the denominators. Are you okay with that? Now, once you have the direction vector, then what we have to do is get the normal vector of the plane, right? So from the plane, we have been given 2x plus y minus z equals what? 8, right? So the normal vector is basically 2, 1, and negative 1, right? So the normal vector is the coefficient of x, y, and z. So the normal vector is n equals 2, 1, negative 1, right? So if you have an equation and you want to find the normal vector of that particular equation, the normal vector is the coefficient of the unknown, which is x, y, z. So take note. The normal vector here is 2, 1, and negative 1. Now, once you have the normal vector, then we can say that, so our normal vector, which is equal to 2, 1, and negative 1, we have here. Then what we do is that we pick a point on the line by letting t equal 0, right? So we pick a point on the line by letting t equal 0. So if we let t equal 0, then we can say that, you see, we have x equals 1 minus 2t. So if we let t equals 0, that is a point on the line. So we are letting t equals 0. So if t equals 0, that means that x will be what? 1. And as well, y equals 2 plus 5t. And if t is 0, that means y is what? 2. And z is what? Negative 3t. So if t is 0, so it means that our z will also be 0. So these are the points on the line. Now, what we have to do is that we have to check if these points, right, on the plane, if these points satisfies the plane. So what we are going to do is that we are going to substitute the value of x, the value of y, and the value of z into the equation and see if it is going to what? Satisfy this equation. Because what we are going to have here should be equal to what is going to be here. If it is not the same, then it does not satisfy the equation, right? So we're going to have 2 into x is 1 plus y is 2 minus z 0 equals 8, right? So 2 plus 2 is 4. And 4 is not equal to 8. So the point does not satisfy, or the point is not on the plane. The point is not on the plane. So the line does not lie on the plane. So this line does not lie on the plane. Okay, so we have to go ahead and check if the line is parallel to the plane. So the option A is ruled out. Option A is ruled out. So we picked a point and we checked and it does not lie on the plane. So option A is ruled out. Now let's check option B. Option B says the line is parallel to the plane. So if it's going to be parallel to the plane, then you have to check that as well, right? So we have to compute the dot product of the lines. So we have to compute the dot product of the line. Right, so the dot product of the line direction vector and the plane's normal, right? So the direction vector, so we're going to find the direction vector, the dot product of the direction vector and the normal. So we have 2 neg 2 5 neg 3 dot 2 1 neg 1, right? So the dot product will be equal to this and this will give us -4. This and this will give us 5. This and this will give us +3. So our dot product will give us -4 plus 5 will give us +1. +1 plus 3 is 4, right? And 4 is not equal to 0. You know, when we take the dot product, it should be giving us 0. So this is not equal to 0. Therefore, the second option as well has been ruled out. So the second option has been ruled out. So we have to check the third option. So we check the third option. Now, since it is not perpendicular and doesn't lie on the plane, and the dot product is non-zero, it means the line is not parallel either, right? So we can conclude that the line is neither parallel nor perpendicular to the plane. So we can say that hence the line is not parallel. The line is not parallel nor perpendicular to the plane. So this should be your right answer to question number 7. I understand, and I know you know how you know how to walk through the process whenever you have a problem of this nature. Okay, so let's move on to question number 8. Okay, so with question number 8, we want to find, or we want to check that we have been given some options and want to find which of the following is a unit normal to the surface sy equals z squared at the point 1, 1, and -1. Okay, so first of all, if you have a problem, right, a surface sy, any surface, right, at a given point, and you want to find out if that particular surface is a unit normal to that particular surface at that given point, then first you have to express the surface as a level surface, right? So step one, express the surface as a unit, as a level surface, right? So you express the surface as a level surface. Thus, you rewrite thus you rewrite you rewrite the function, right? F of x, y, and z, which is equal to xy equals z squared, right? And this is equal to what? 0. So we say that f of x, y, z is equal to xy minus z squared, right? So basically this is equal to 0. Now, then once you have this, then it means that your gradient vector is normal to the surface. So step 2, let's let us compute let us compute the gradient of the surface, right? So the gradient of the surface will be given as partial derivative of the first variable plus partial derivative with respect to the second variable, partial derivative with respect to the third variable, right? So this is how we find the gradient. We take the partial derivative of the function with respect to x, partial derivative of the function with respect to y, and then partial derivative of the function with respect to z, and that becomes your gradient. So we are going to have our gradient to be equal to, when you differentiate this function with respect to x, we are going to have y minus z squared, right? So we have y minus, with respect to x, right? So we're going to have y. So we have y, comma. And then with respect to y, we are going to have x. And then with respect to z, we are going to have minus 2z, right? So this is the gradient, right? Now, at this given point, right? So it means that we have to substitute the point inside. Okay, so at 1, 1, neg 1, we have our gradient to be equal to 1, 1, and negative 2 is what? Neg 1. So we have our gradient to be 1, 1, and 2. Right. So once we have the gradient, the normal to the gradient becomes the normal to the gradient. So the normal to the gradient is I plus j plus 2k, right? That is our n, small n. So that is the normal to the gradient. Now, once we have that, then means we have to convert this to unit vector, right? And first, we need the magnitude of the normal. We know that. So once we have the magnitude of the normal, then we are good to go. So the magnitude of the normal will be equal to square root of 1 squared plus 1 squared plus 2 squared, right? And that will be equal to 1 plus 1 is 2 plus 2 squared is 4. So it's equal to 6. So the magnitude of the normal is square root of 6, right? And if you know that if you want to find the unit vector, then you have to take this and then you take this, right? So our unit vector, our unit normal vector to the surface becomes I plus j plus 2k, all divided by square root of 6, right? So our unit normal to the surface is I plus, or we can write it as 1 over square root of 6, 1 over square root of 6 times I plus j plus 2k, right? So this becomes our unit normal to the surface xy minus z squared at the point 1, 1, and negative 1. So if you have a surface, right, at a given point, and you want to find the unit normal vector, then first you have to find the gradient. Once you have the gradient, the result that you obtain for the gradient becomes your normal, right? So once you have the normal, you just have to find what? The magnitude of the normal. Then you know that unit vector or unit normal vector is what? The position vector of the normal over the magnitude of the position vector. You are good to go. So now let's move on to question number 9. Okay, so question number 9 is having the same feature as question number 8, right? We have been given some options and you want to find which of the options is the angle between the surfaces z equals x squared plus y squared minus 3 and s squared plus y squared plus z squared equals 9 at the point 2, -1, and 2. So it's just like the question number 8. So first of all, what you have to do is that you have to express each of the surface as a level surface, right? So first, step 1, express each surface as a level surface, right? So once you do that, then these are the surfaces, right? These are the surfaces. So let's say that the first surface is called f of x, y, and z, and that is equal to z squared. That is equal to z minus s squared minus y squared plus 3 equals 0. Yeah. Or we can say that f of x, y, and z is equal to x squared plus y squared minus z minus 3 equals what? 0. And that is from this, right? So I just expressed it, I just sent this to this side and equated it to 0. Okay, let's say the second one is g of x, y, z equals what? The second surface, which is s squared plus y squared plus z squared equals 9, right? So with that too, we bring the 9 to this side and then set the whole equation to 0. So we're going to have j of x, y, and z to be S squared plus Y squared plus Z squared minus 9 equals 0. Right, so we have that we have been able to express the surfaces in a level surface form. So the next thing we have to do is to compute the gradient of each of the what surface, as we did in question number 8. So let's have some short break. We come back. We'll come back from the short break. So we ended here, and we have been able to express each of the surfaces as a level surface, right? So now, step two. We have to use the level surfaces, right? Each of the level surfaces, we are going to find the gradient, right? So the gradient for a function f of x, y, and z will be equal to, we are differentiating this function with respect to x, right? So with respect to x, we are going to have 2x, right? And also with respect to y, with respect to y, it also 2y. With respect to z is minus 1, right? So this is our gradient for this particular function. Are we okay? When you are finding the gradient, you differentiate each of the functions, right? Each of the variables with respect to. So we take x, differentiate with respect to x, you have 2x, comma, differentiate y with respect to y, you have 2y, then differentiate minus z with respect to z, you have what? Minus 1. Now, we have to evaluate this gradient at 2, neg 1, and 2. So 2, neg 1, and 2. So gradient at 2, neg 1, and 2 will be equal to, we are going to substitute into this, right? So that means that our x is 2, y is neg 1, and z is 2, right? So we are going to have 2 into 2, comma, 2 into neg 1, comma, our z is already negative 1, so we don't have to substitute anything. Now, we are going to have 2 neg 1, 2 equals 2, 2, 4, comma, this will give us minus 2, then we have minus 1. So we have been able to evaluate the first function, right? The first function at the given point. We have to also find the gradient for the second function, and then we evaluate it at the given point. Okay, so the second function is j of x, y, z, and that is equal to, when differentiate x squared, you're going to have 2x with respect to x, right? Then, comma, you differentiate y squared with respect to y, you're going to have 2y. Then you differentiate z squared with respect to z, you're going to have 2z. Then you differentiate negative 9, you're going to have 0. Differential of a constant is a 0. Great. So this is our gradient. So now we have been able to obtain the gradient for the second function. So we are going to evaluate it at the same point. So evaluate at 2, -1, and 2. So that means that x is 2, y is -1, and z is 2. So our gradient at 2, -1, and 2 will be equal to 2 into 2, comma, 2 into -1, comma, 2 into 2, right? So we have our gradient at the evaluated point to be, this will give us 4, this will give us -2, and this will give us 4. Okay, so this is our gradient for the two functions at the evaluated point. Now, we are interested in the angle between the two surfaces, right? So once we have the gradient for the first function, the gradient for the second surface, then we have to take the dot products, right? And you know that when you are taking the dot product, you find the dots of this to this, then it means you're going to have this dot this, and that will be equal to, this is what, 4 -2 -1 dot 4 -2 4, right? So this will give us 4 4 16, right? Plus -2 times -2 becomes plus 4. -1 times 4 becomes -4, right? So our dot product will be equal to this and this and this will give us 16, because this will cancel this. So this is our dot product for the two functions, right? So we have 16. Now we are interested in the angle, right? That is our point of interest. So the next thing we have to do is we have to find the magnitude for the first function, then we also find the magnitude for the second function. Then guess what? We are going to apply the formula that we know. So from here, we know that magnitude of f will be equal to, this is our f, right? So magnitude of that will be equal to square root of 4 squared plus -2 squared plus -1 squared, right? So we have that to be, this will be 16, right? 16 plus 4 plus 1, and that is equal to 20 plus 1 is 21, right? So the magnitude of f, right, is square root of 21. Okay. We also have to find the magnitude of the second function. So the magnitude of the second function will be equal to square root of 4 squared plus -2 squared plus 4 squared, right? So we are going to have 4 squared is 16 plus 4 plus 16, right? So we are going to have 16 plus 16 is 32. 32 plus 4 is 36, right? So we have 36. Great. So the magnitude of the second function is what? Square root of 36. And we know that if you want to find the angle between two surfaces, then you just have to apply the formula, right? And as usual, you know that our formula is a dot b a dot b our formula is, so here we are going to use the gradient, right? So right equals magnitude of f times magnitude of j times cos theta. Right, so we have this, we have that, we have that. So we're going to have cos theta equals gradient of f times gradient of divided by magnitude of this times magnitude of that, right? And then this was 16. And then this is also square root of 21 times square root of 36. Great. So we just have to simplify it and then we are good to go. So so that is basically going to be, when you simplify this, you are going to have cos theta equals 16 over square root of 21 times square root of 36 is basically 6 times square root of 21, because square root of 36 is 6, right? So we have 6 times square root of 21. Okay, so we can say that, you know, this 16 over 6 times square root of 21 can be simplified further, right? I hope we are good with that. So 3 will go here, or 2 will go here, 3, and 2 will go here, 8, right? So we have cos theta equals 8 over 3 times square root of 21. Okay, so we can say that our cos theta is equal to this, but we are interested in the angle, not cos theta. So we say that cos our theta is equal to cos inverse of 8 over 3 times square root of 21. Are we okay with that? So simple, right? So basically, if you want to know the actual value, then you just compute this using your calculator, right? So I can say that this is equal to cos inverse of 8 over 3 times square root of 21. And that is our solution to question number 9. So amazing, right? So let me give you an overview for um, question number 9. You know, question number 9, we're given two surfaces, right? Surface 1, surface 2 at a given point. And we are asked to find the angle between these two surfaces. So first of all, we have to express these two surfaces as a level surface, right? So in that sense, it means we are going to um, express all this function. Maybe we are using f of s, y, z, right? So if you use f of s, y, z for the first function, then you take this to this side, then equate all to 0. That is, you are expressing it as a level surface. Then the second function, so you can use g of x, y, z, or h of x, y, z, right? Then you bring this here, equate all to 0. That is the level surface, right? Now, once you have the level surface, take each function, find the gradient. So if you take this function, once you express it as a level surface, take it, find the gradient of it. And you know that if you want to find the gradient of a particular function, just have to differentiate the function with respect to x, comma, differentiate the function with respect to y, comma. If there is z, differentiate the function with respect to z. Once you are done, the three point that you have becomes your what? Your gradient. So you have what? Three component. If it is x, y, z, you have three component. If it is x, y, you have two components. Once you are done, then you evaluate it at the given point. Then you have your actual gradient. So the actual gradient that you'll be having for the first surface, you put it down. Then you come and do the same process for the second surface. Once you have the gradient for the second surface as well, find the dot product. Once you have the dot product, put it down. Come and find the magnitude of the first surface, find the magnitude of the second surface, then use the formula to find the angle between the two surfaces. Great. So let's move on to question number 10 so that we move so quick. Okay, so with question number 10, we want to know which of the following shows the application of the dot product. The application of the dot product, right? So I'm coming to mention the options to you, and then we walk through each of the steps. So option 1 or option A, projection of one vector on another. Projection of one vector on another. Option B, area of triangle. Option C, unit vector perpendicular to two vectors. And then option D, collinearity of two vectors. Collinearity of two vectors. So I want to know which of these aforementioned vectors, shows the application of dot product. So we are going to begin, right? So that we know which of them shows the application of dot product. So basically, for us to be able to know the one that shows the application of a dot product, then we have to know that if you have two vectors, okay, so for instance, if you have two vectors, say vector A and vector B, okay, right? And you know that the dot products between the vectors is given as A dot B equals magnitude of A times magnitude of B cos theta, right? So that is the dot product between the two vectors. For instance, if you have two vectors, okay? Now, we know that this theta here, the theta here is the angle where theta is the angle between A and B, right? So the angle between them. So let's try to analyze this information that I've put forward. So first of all, let's say that we are having a projection of one vector on another, which is the option A. That is projection one vector on another. So basically, if you project one vector on another, let's say you are projecting vector A and B and you are using the dot product, right? Then it means that you are going to have projection of vector B on A, right? Projection of vector B on A. Vector A on B, right? So that is vector A on B. You are projecting vector B, A on B, right? And that is equal to A dot B, right, over magnitude of B. That is, if you project vector A on vector B, that is how it goes, right? So that is projection of one vector on another. And that is right. So if you want to find the area, so the first option, which is option A, is right, because if you have two vectors, okay, so vector A, vector B, the dot product between these two vectors is giving us this. Now, and you know that the angle between them is theta, right? Okay. Now we are projecting vector A on vector B, and that is what we have here. And if you project vector A on vector B, this is how it's going to be. Am I okay? So it means that if you want to find the magnitude of B, just have to cross this way. Then you have A dot B, of which is going to be given as this, right? And then if you cross this here, then it means that this and this, you're going to have the magnitude of A and the magnitude of what? B. You know, and you know that when you project something on something, there is an angle between them. And that is what is here, right? Now, let's look at the area of triangle. So, option B. So, the option A, the projection of vector A and B uses the dot product. So, it is an application of the dot product. So, projection of one vector on another is an application of the dot product. So, take note. Let me write it here. Projection of one vector on another is an application of the dot product. It's an application of the dot product. Now let's look at the area, right? Area of triangle. The reason why the area of triangle will not be an application of a dot product. Now, you know that area of a triangle, of which is not going to be facts, area of a triangle involves the cross product. You know that from the beginning. I think we've not solved any question that involves that, but you know that area of a triangle involves the cross product, right? And area of a triangle involves cross product. And not the dot product that we are interested in. You know, in here we are interested in the dot product and not the dot products that we are interested in. So basically the area of a triangle is automatically out, because if you are talking about area of a triangle, then it means you are going to use the what? The cross product, of which it doesn't relate to dot product. So basically the area of a triangle is ruled out. So I want you to know that area of a triangle is basically equal to half of the magnitude of this. So this is how we obtain area of a triangle, of which it doesn't relate to the dot product at all. Now let's look at the next option, which is unit vector perpendicular to two vectors. So unit vector perpendicular to two vectors. Unit vector perpendicular to two vectors, right? With that two, we cross it out. It's not an application. It's not an application of a dot product. Why? This is from the cross product. It is from the cross product that we get the unit vector perpendicular to two vectors. So it is not an application of the dot product, right? So the reason is this is from the cross product. This is from the cross product, which gives a vector perpendicular to both, right? So once you hear unit vector perpendicular to two vectors, it's never an application of a dot product. And also area of a triangle is not an application of a dot product. So these two are also ruled out. But this is working. Okay. So the last part, which is the collinearity. Now, the collinearity nearly succeeded, right? It nearly succeeded because looking at the collinearity, we know that collinearity of two vectors, this is partially true. You know why I say this is partially true? If you have two non-zero vectors and they are collinear, then the angle between them is either 0 or 180 degrees. If you have two vectors, and they are collinear, then it means that the angle between them is 0 degrees and 180 degrees. So that is why it is making the collinearity partially true. And so we cannot add it to the applications of the dot product. So if you have two vectors and they are collinear, then the angle between them is what? 0 degrees and 180 degrees. So the dot product is A dot B equals cos theta. And you know that A dot B is equal to and also when theta is equal to 180 degrees, then we have A dot B to be equal to negative times magnitude of A times magnitude of B. You know, cos 180 is what? Negative 1, right? So once you have 180, then it means that you are not going to have what? A dot, the formula for the dot product. So that is why the collinearity is partially true. If not because of the 180, then it would have worked. But because of the 180 degrees, it won't work. So it is partially true. So we rule that one too out. So this is also out. Right? So the only standard way, or the only standard application of the dot product is the projection of one vector on another, the projection of one vector on another, the projection of one vector on another. That is the standard application of the dot product. So interesting, right? Now let's move on to question number. Okay, so with question number 11, we want to find the value of x, some unknown, if a vector A equals 4i plus 11j plus xk and B equals 7i plus 2j plus 6k and C is equal to I plus 5j plus 4k are coplanar. We want to find the unknown in the position vector A, which is x. Okay, so we know that if vectors are coplanar, then it means that their scalar triple product is basically what? 0. If vectors are coplanar, then means that their scalar triple product is basically what? 0. So that is the rule. If vectors are coplanar, then their scalar triple product is 0. So that is A dot B cross C is equal to 0, right? So you just have to follow this principle and you are good to go. So what do we need here? We first have to find, mathematics. When you are talking about mathematics, once you hear brackets first, you have to apply the bracket first, right? So board mass applies. We apply the bracket first, then we followed by the dot. So we are going to take this, work it, then after we dot it with the A. So we have to find step 1, B cross C, right? And that we are going to use the cross products, right? So we have I, J, K. And our B here is 7, 2, 6. And our C is 1, 5, 4. Right. So we are going to have I into 2, 5, 6, 4 minus J into 7, 1, 6, 4 plus K into 7, 1, 2, 5. Right. So we have to break this down to find B cross C. So our B cross C will be equal to I into this times this is 8, right? So we have 8 minus 5 times 6 is 30, right? So we have 30 here minus j into 4 times 7. 7 for 28, right? So we have 28 here minus 6 times 1 is 6 plus k into 6, 7, 5, 35, right? So we have 35 minus 1 times 2 is 2. So we have B cross C to be equal to I into 8 minus 30 is basically minus 22. So we have minus 22 minus j into 28 minus 6, right? Is basically 22, right? So we have 22 plus k into 35 minus 2 is 33. So we have 33. So B cross C will be equal to minus 22I minus 22J plus 33K. So this is our B cross C. So once we have B cross C, we just have to dot it with what? The A, position vector A. So from here, A dot B cross C will be equal to, our A is 4I plus 11J plus XK dot the B cross C, which is negative 22I minus 22J plus 33K, right? So we're going to have, we do it component wise. So this times this, 4 times minus 22, right? So that is going to be 4 times minus 22, and that is going to be minus 88. Then 11 times minus 22, and that is minus 242. Then x times 33 is plus 33x. So you know that all this should be equal to what? 0. So when you add this and this, you're going to have 330. So we have minus 330 plus 33x equals 0. So we're going to have 33x equals 330. So our x will be equal to 330 divided by 33, and that is equal to 10. So our value of x is basically what? 10. Okay. So let me conclude. Let me conclude here. So that's the value of x is equal to 10. The value of x is equal to 10. So whenever you have vectors, all right, with some unknown, and they say that these vectors are coplanar, then record that coplanar vectors, if vectors are coplanar, then their scalar triple product is equal to 0. Their scalar triple product is equal to 0. Note, scalar triple product here means that if you have A, B, C, then it means that A dot B cross C is equal to what? 0. And remember, whenever you have A dot B cross C equals 0, work this first. When you are done, you dot it with the first vector, then equate it to 0, find your unknown, and then you are good to go. So interesting, right? So that is 10 we have here. Now let's move on to question number 12. Okay, so with question number 12, we are given this particular function, right? We are given this particular function, u, right? And we want to find the second partial derivative of the function with respect to y and z, with respect to y and x, okay, at the given points 0 and 1. Now, this problem is basically mixed partials. It's called mixed partial. So we are going to apply the knowledge of mixed partials. Okay, so this here, right, means that we are going to differentiate the function. So this is equal to differential of the function first with respect to x. So we differentiate the function first with respect to x, then the result that you obtain, use that result to differentiate again partially with respect to y. Then you substitute the point. That is it. Very simple, right? So we are going to begin with this. Then the result you obtain, use it to differentiate this with respect to y. So let's start with respect to x of this function, right? So with respect to x of this function is going to be, we are differentiating this function with respect to x, is going to be 2x plus x to the power y with respect to x is y x to the power y minus 1, right? Plus, when you differentiate e to the power x over y with respect to x, you are going to have e to the power x over y. Then you differentiate x over y with respect to what? X. That is the same as this, right? So you're going to have y to the power -1. So we're going to have 1 over y here. So this becomes our derivative to the function in the bracket. Okay, so once we have the derivative of the function with respect to x, then we use the result that we obtain to differentiate again with respect to what? Y. So the next derivative is going to be with respect to y of this function. So 2x plus y, x to the power y minus 1, plus e to the x 1 y, e to the x over y, right? Now, we are differentiating this function with respect to what? Y. We are differentiating this function, right, with respect to y. So let's consider it one by one so that it doesn't look so bulky, right? So we consider 2x, right? So when you consider 2x, you differentiate with respect to y, you have 0. You have 0. Then we consider this. Consider y, x to the power y minus 1. Right, so we are considering this. Now we are coming to differentiate with respect to what? Y. So here, we are going to use what we call the product rule because we have one function, another function. So we have to use the product rule. And they are stacked together. So there is no option than to use the product rule. So in here, we say that we differentiate this we maintain this. So we're going to have, when you differentiate to y with respect to y, we're going to have 1. So we have this maintained. Plus, we maintain this, then we differentiate x to the power y minus 1, right? And don't forget, if you are differentiating x to the power y minus 1, then it means that you are going to maintain x to the power y minus 1, then you're going to have times ln x. We let this function equals f of y, and let's say that if f of y is equal to a to the power y, a to the power j of y, then it means that, for instance, we're going to have our a to be equal to x, right? Our a here will represent our x here, right? And then our j of y will be equal to the exponent, which is y minus 1, right? So if that is the case, then it means that our j prime of y will be equal to 1, right? From here. Now, if g prime of y is equal to 1, then it means that our derivative of the function with respect to y will be equal to x to the power y minus 1 ln x times 1, right? X to the power y minus 1 ln x times 1. So basically, we are going to have x to the power y minus 1 ln x. So when you differentiate this function, you're going to have x to the power y minus 1 ln x. So now we have been able to differentiate the second part with respect to what? Y. We have to also consider e to the power x over y all over what? Y. So we consider e to the power x over y divided by y. So in here too, we are going to use the product rule. Okay, we are going to use the product rule and the chain rule all together. So we have to let u equals 1 over y, okay, and v equals e to the power x over y. Okay, so if that is the case, then it means that our u prime will be equal to negative 1 over y squared, and our v prime will be equal to yeah, and our v prime will be equal to negative x over y squared e to the power x over y. And when we differentiate this function, you're going to have, you maintain this, then you differentiate the function at the top with respect to what? Y. So you're going to have x over y squared, and that's be negative. Okay, so now that we have all the informations, let's apply the formula. So that will be equal to derivative of e to the x over y all over y with respect to y will be equal to u times u prime times what? V. And that will be negative e to the power x over y divided by y squared minus 1 over y cubed. That will be x over y cubed e to the power x over y. So we say that our derivative of the function u with respect to y and x is equal to x y to the power 1 y minus 1 plus this, which is y x to the power y minus 1 ln x minus e to the power minus e to the power x over y divided by y squared minus x over y cubed e to the power x over what? Y. So we can see that this is common to these two terms. So we can factor this out. And this is also common to these two terms. So we can factor that out. So, right, so we can leave it that way, right? So we see that the second derivative of u with respect to y and x will be equal to x to the power y minus 1 plus y x to the power y minus 1 ln x minus minus e to the power x over y into 1 over y squared plus x over y cubed. Right, so this becomes our solution to this particular problem. Now, we have to evaluate it at what? 0 and 1. That means that when we substitute 0 here, this goes to 0 plus when you put, you're going to have 1 times x is 0 to the power 0, right, times ln into 0 minus e to the power 0 into 1 over 1 plus 0 over 1, right? So we're going to have, this will give us 0 plus 1 times 0 to the power 0 is 1, right? So 1 into brackets 0 to the power 0 is 1. And then we have ln 0 is also 1, right? So we have 1 here minus 1 into bracket 1. So we're going to have 1 minus 1, and that is equal to 0. So that means that when you evaluate the second partial derivative of this function with respect to y and x at the points 0 and 1, you're going to have what? 0. Now, without the evaluation, then means that this will be your what? Your second partial derivative of u with respect to y and x. But when you evaluate this function that you obtain at 0 and 1, then you have what? 0. So that is question number 12. Now let's move on to question number 13. question number 13, it's basically a mixed partial derivative, right? And this is third partial derivative. So first of all, you have to differentiate partially with respect to z. Then after you come to y and x. Okay, so the cube of u with respect to x, y, and z, we are going to start with respect to z. So of u, right? Now, x, y, the u of z, right? So we are going to begin with the z. So we begin with the z of the function, which is e to the power x, y, z. And you know that if you want to differentiate an exponential function, then you have to maintain the exponential function. Then you differentiate the exponential function with respect to the variable that you are interested in. So we are interested in z, right? So we differentiate with respect to z. You have what? Times x, y, right? So when we differentiated with respect to z, we have this result. So that u with respect to z is equal to xy e to the power xy z, right? So this is what we have. Now, we want to differentiate this function again. This is the result we have now. So we have to differentiate now with respect to what? Y. So second partial derivative of u with respect to x, right? So we're going to have the squared u with respect to y, and this is our function now. So xy e to the power xy z, right? Now we are going to differentiate it with respect to what? Y. You know that this we are going to apply the product rule, and you know that the product rule says that when you have two functions stacked together and you want to differentiate them, then you have to apply him. So first of all, we let u equals xy, then v equals e to the power xy z, right? So u prime with respect to y will give us x. V prime with respect to y will give us x z e to the power xy z. Right, so this is the result that we have for differentiating this particular function. So let's apply the formula. So we're going to have u prime times v. So we have x e to the power xy z plus u times v prime. So we have xy times xz e to the power xyz. So basically we're going to have x e to the power xyz plus this, and this will give us s squared y z e to the power xyz. Right, so this is the result that we obtained from the second partial derivative with respect to what? Y. Now, this result that we have, we are going to differentiate it partially with respect to what? X. So finally, we are going to have the cube u with respect to die x, and that will give us x e to the power xyz plus x squared yz e to the power xyz, right? So we are going to differentiate this with respect to x, right? So we let u equals x, v equals e to the power x, y, z, right? So u prime will be equal to 1 and v prime will be equal to, we are differentiating with respect to x, right? So we're going to have y, z, e to the power x, y, z, right? Don't forget that it's two functions, right? So this is the first result for differentiating. So let's apply the product rule here. U prime is 1 and u is x e to the power x, y, z plus u x and u prime is y, z e to the power x, y, z. So this is the result for differentiating the first term, right? So let's go ahead and differentiate the second term as well with respect to x. So with respect to x, again, with respect to x of the second function, xy, s squared yz e to the power x, y, z, right? So our u here is s squared yz and our v is e to the power x, y, z, right? So u prime with respect to x will give us 2x, y, z, and v prime with respect to x will give us yz e to the power x, y, z, right? So we are going to have u prime 2x, y, z, and v is e to the power x, y, z plus u, which is x squared yz, and v prime is yz e to the power x, y, z, right? So we can say that we have 2xyz e to the power xyz plus this will give us s squared y squared z squared, right? E to the power xyz. So this is the result we obtain for differentiating the second term as well. So this is what we have for the third partial derivative of this function. Now, let's combine the two so that we can evaluate it at the point 1, 1, 1. So when we combine the two, di cube u with respect to di x, di y, di z, we are going to have e to the power xyz plus xy z e to the power xyz plus 2xy z e to the power xyz plus x squared y squared z squared e to the power xyz. Right, so this is what we have for differentiating this particular function 3 times with respect to x, y, and z. Now, we want to evaluate it at 1, 1, 1, right? So, we're going to have the cube u with respect to x, y, and z at 1, 1, 1, right? So, this is basically telling us that x x is equal to 1, y is 1, and z is also 1. So when we do that substitution, then we're going to have e to the power 1 into 1 into 1, right? Plus 1 into 1 into 1, right? E to the power 1 into 1, right? Plus 2 into 1 to 1 into 1. E to the power 1, 1, 1. Plus 1 squared, 1 squared, 1 squared. E to the power 1, 1, 1. Right, so this will give us e plus this will give us e. So plus 2e plus another e, right? So 1, 2, 1 plus 1 is 2. So we have 2e plus this will give us 3. So we have 3e. So in all, we have 5e. Great. So this becomes the result for differentiating this particular function at 1, 1, 1. It's great, right? So just have to follow the steps one by one and know how to use the product rule. Once you know how to use the product rule, you are good to go. So let me write the final answer here again. So we had 5e for differentiating this particular function at 1, 1, 1. So first, what you have to know is that when you have mixed partial derivative, you start from the back because it is not continuous, right? So order matters. Okay, so we start from the back with respect to z, then you move to with respect to the result that you get from differentiating with respect to z. Use that result to differentiate partially with respect to y. Then the result that you get for differentiating partial with respect to y, use that result to differentiate partial with respect to what? X. Then that becomes your mixed partial derivative, your third mixed partial derivative with respect to what? X, y, and z. And at the given point, 1, 1, 1. And we had what? 5e. So great, right? Now, let's move on to question number 14. With question number 14, we are given two functions, okay, of which f of x and y equals this function and g of x and y equals 3x squared y. Now, we are given four options involving partial derivative of f and g. So we will compute the necessary partial derivatives of each and then we'll compare, right? So we are working towards this, right? So die f with respect to die y is equal to negative die j with respect to die x. Okay, so we are working towards this particular option. Now, first of all, we have to let's write our functions. F of x and y equals x cubed minus 3xy squared, and g of x and y equals 3x squared y. Okay, so first of all, we have to differentiate the first function with respect to x, right? The f with respect to x. So the f with respect to x will be equal to 3s squared minus 3y squared, right? So that is the result of differentiating the first function with respect to what? X. The step 2 is to differentiate the second function as well with respect to what? X. So the j with respect to x will be equal to 6xy. Okay, so we have the first derivative of the first function with respect to x, and the second derivative, the second function to find the first derivative of the first function with respect to what? X. Right. So once we have with respect to x and we have this, then we also have to differentiate the second function with respect to x, and also we have this. So we have to differentiate the first function again with respect to y, and that is going to be negative 6xy. Okay, and we have to differentiate the second function as well with respect to y. This with respect to y, so we're going to have when you differentiate this with respect to y, then you're going to have 3x squared, right? So this is what we have for differentiating the second function with respect to what? Y. And this are what? They are not the same. But we know that when we negate when we negate when we negate this, right? When we negate this, we are going to have the same as what? This. So when we negate the j with respect to x, we are going to have the same result as what? This. So we can say that negative of the j with respect to x will be equal to the f of the y, right? So we are going to have the f with respect to the y to be equal to negative of the j with respect to what? The x, okay, of which we have here, because this is the option that we are working towards. Are we okay? So this becomes our right answer as we are interested in here. So that is basically question number 14. Now let's move on to question number 15. Okay, so with question number 15, we are given this preamble, right? That suppose an object position in space at a given time t is parameterized by this position this position vector r of t equals negative 9 ln t, comma, sine pi t over 3, comma, t to the fourth plus 2t, right? For t belongs to what? T is greater or equal to what? 0. Now, we want to find the object's velocity at time t equals what? 3. So the velocity is basically equal to what? The derivative of what? The position vector. So velocity of the function at time t is equal to the derivative of what? The position vector. So when we find the derivative of this, then we are good to go, right? We just have to substitute t equals 3, then we get the object velocity at that time, right? So we are going to say that r of t will be equal to negative 9 ln t sine pi t over 3 t to the fourth plus 2t, right? So let's consider them one by one to differentiate. So we consider negative 9 ln 10, negative 9 ln t, right? So when you differentiate negative 9 ln t, derivative of that with respect to t, we are going to have negative 9 times derivative of ln t is what? 1 over what? T. Okay? And we know that it is what? As t equals what? 3. So we have negative 9 over t, and that will be equal to negative 9 over what? 3. So basically, we're going to have what? 3 for the first component, right? After differentiating negative 9 ln t, then we evaluated at what? T equals what? 3. And then we have 3. So let's consider the second component, which is sine into pi t over what? 3. Right. So if you want to differentiate sine pi t over 3, then you have to apply the implicit differentiation, right? So basically, we are going to use the implicit differentiation. So we're going to differentiate this sine, right? So differentiate sine with respect to what? T, right? You know that when you differentiate sine, you're going to have what? Cos. So we have cos into pi t over 3. Then we differentiate the inner function with respect to what? T. So we are going to have pi on 3. So times pi on 3. So we have pi on 3 cos into pi t over what? 3. So this is the derivative for differentiating sine into pi t over what? 3. Now, at t equals what? 3. We are going to have pi on 3 cos into pi times what? T is 3 over what? 3. And that would be what? Pi on 3 cos into pi. And we know that cos pi is basically negative 1, right? Cos pi is negative 1. So we are going to have negative pi over 3. Negative pi over 3 for differentiating this at t equals what? 3. Now, we consider the last component, which is t to the fourth plus 2t. So we consider t to the fourth plus what? 2t. So we differentiate that with respect to what? T, right? So we're going to have the derivative of t to the fourth with respect to t, you're going to have 4t cubed plus derivative of 2t is 2. Now, at t equals what? 3, we are going to have 4 into 3 cubed plus 2, right? So this is going to give us 4 into 3 to the power 3 is basically 27, right? So 27 plus 2. So 4 times 27 plus 2 is basically 110, right? So 110 for differentiating the last component with respect to what? T, and evaluating at what? T equals 3, we had what? 110. So that means that our velocity at time t equals 3 is basically obtained as -3, comma, the second part is -pi on 3, and the third part is 110, then close our brackets, right? So that becomes our final solution to that particular problem. So that becomes our final solution to this particular problem. So the velocity the object's velocity at time t equals 3 is given as -3 minus pi on 3 and 110. So this becomes our final solution, right? This as well, you can write it -3 -pi on 3 110 in an angle bracket form. These are all the same. Okay, so this becomes our final solution to question number 15. Now let's move on to question number 16. Interesting, right? So with question number 16, we are using the same preamble, okay? Now, 15, we obtain the velocity, right? In here, we are trying to find the object's acceleration. And we know that acceleration, which is a of t, is equal to derivative of the velocity, right? So whatever we had for the velocity, we are going to differentiate it. Then we have what? Acceleration. So acceleration will be equal to, we know that our velocity we had -9 over negative t over -9 over t, comma, pi on 3 cos into pi t on 3, and then we had 4t cubed plus 2, right? So this is what we had for velocity. So we are going to differentiate this velocity to have acceleration. So we consider them 1, 1. So we're going to consider -9 over t. You're going to differentiate this, right? So differentiate this with respect to t. We are going to have, this is the same as derivative of this function like this, right? So we're going to have 9 times t to the power -2. So that will be equal to 9 over what? T squared. So this is what we have for differentiating the first time. Now, at t equals 3, we are going to have 9 over t squared. And that will be equal to 9 over 9, which is equal to what? 1. Right? So we have been able to differentiate the first component, and we've evaluated it at what? T equals 3. So let's put that down here. So that is our first component for the acceleration. So we are going to take the second component, which is pi on 3 cos into pi t over 3. Right? So we differentiate this with respect to t. Right, so we know that this is a constant. So we factor that out. Then we differentiate cos pi t over 3. right? So when you differentiate cos, you're going to have negative sign. So you have negative sine into pi t on 3, right? Then we differentiate the inner function again with respect to t, and that is going to give us pi on 3. So we have pi on 3, right? So this and this is going to give us negative pi squared over what? 9 sine into pi t over 3. Okay, so at t equals 3, we are going to have negative pi squared over 9 sine into pi times 3 over 3, right? So we're going to have negative pi squared over 9 sine pi, right? And we know that sine pi is 0. So the whole of this will go to what? 0, right? So the second component is what? 0. So beautiful, right? So let's look at the last part, which is the third component. The third component, which is this. So 4t cubed plus 2. We are differentiating that with respect to what? T. So we're going to have, when you differentiate 4t cubed, you're going to have what? 12t squared. When you differentiate 2 with respect to t, you're going to have what? 0. So at t equals 3, we have 12 into what? 3 squared. And that will be equal to what? 12 into what? 9. And 12 times 9 is 108. Okay, so we have 108 for the third component. Okay, 108. So we have been able to differentiate all. Okay, and we've evaluated them as well. So we can say that our acceleration at time t equals 3, the acceleration, the object's acceleration at time t equals 3 is equal to 1, 0, 108. So beautiful, right? So this is what we have for our acceleration at time t equals 3. And that is question number 16. Let's look at question number 17. So with question number 19, we have a particular curve, okay? And we have been given its position vector, okay? And you want to find the unit tangent. So what you have to know about unit tangent is that when you need unit tangent, it means that you have to differentiate the position vector. And when you differentiate the position vector, you're going to have what? Velocity. Now, once you have the velocity, the formula is this over what? The magnitude of what? The velocity. That will give you what? Your position, your unit tangent. So this is what you need, okay? So unit tangent is basically denoted as what? Capital T. So that will be equal to position vector of what? The velocity over the magnitude of what? Velocity, right? And note, velocity is equal to what? Derivative of what? The position vector, which is of r of t. So we're going to what? differentiate r of t, which is going to be r prime of t, then it will give us what? Velocity. So we are going to consider this and differentiate them term by term. Okay, very simple and interesting. So we're going to consider the first term. So we consider 3 times square root of 5 cos t. So you're going to differentiate this with respect to what? T. So when you do that, you're going to have what? When you differentiate cos, you're going to have negative sign. So you have negative sine t times the constant. So let's bring the constant here, right? So this is what we have for the first term. Now let's consider the second term, which is 6 cos t. When you differentiate 6 cos t with respect to what? T, you're going to have negative 6 sine t. So this is the result for differentiating the second component. Now the last component, which is 9 sine t, right? So derivative of 9 sine t with respect to what? T will be equal to, when you differentiate sine, have what? Cos. So we have 9 cos t, right? So this is the result for differentiating the third component. Now, remember that you have to combine all to get your velocity. So our velocity will be equal to the first component, which is negative 3 square root of 5 sine t, and the second component is negative 6 sine t, negative 6 sine t, and the last component is 9 cos t, right? So this is what we have for differentiating the position vector to have our velocity. Now, what we need next is what? The magnitude of what? The velocity. So the magnitude of velocity will be equal to square root of the first component squared, right? Plus this squared plus 9 cos t squared, right? So in all, we are going to have negative 3 square root of 5 sine t all squared is going to be 9 into 5 sine squared t plus 36 sine squared t, right? Plus this will give us 81 cos squared t. So this will basically give us 9 times 5 is 45. So we have 45 sine squared t plus 36 sine squared t plus 81 cos squared t, 81 cos squared t. So we can see that we have sine squared and sine squared, so we add the coefficients, right? So 45 plus 36 is 81. So we're going to have square root of 81 sine squared t plus 81 cos squared t. And you know that we can factor 81 out. So when we do that, then we're going to have the magnitude of the position vector v is equal to 81 out sine squared t plus cos squared t, right? And you know that this is a well-known identity which is equal to 1. So we have square root of 81 into 1. And that is equal to square root of 81 is basically what? 9. So we have 9. Interesting, right? So the magnitude of the position vector v is what? 9. So we are just going to divide the velocity that we have by 9. And that becomes our unit tangent. So our unit tangent t is equal to negative 3 times square root of 5 sine t, comma, negative 6 sine t, comma, 9 cos t will be all divided by 9, right? So I can say that our unit tangent t will be equal to negative 1 over. We can see that 9 is common to all. So divided each of the component by what? 9. So when we simplify it, we are going to have this will go here 3. So we're going to have minus 1 over what? 3 square root of 5 sine t. Then this will also go here. 3 will go here 2 and 3 will go here 3. So we have negative 2 over 3 sine t. And then this will cancel this. So we have cos t. So finally, we can say that our unit tangent is t is equal to negative 1 over 3 square root of 5 sine t, comma, negative 2 on 3 sine t cos t. So this becomes our unit tangent for this particular curve. So one thing you have to know is that if you are interested in finding the unit tangent, then remember that you need the, if you have the position vector, it means you have to differentiate the position vector to get your velocity. Once you have the velocity, find the magnitude of the velocity and then use that result to divide the velocity that you have, and you are good to go. So this is the result for question number 17. Now let's move on to question number 18. Question number 18, I'm not going to solve question number 18, okay? I'm going to give a guidelines so that you solve question number 18. So basically, question number 18, what we are to find is, we want to find the magnitude of A cross B cross what? C. So we all know what this one means. And this question is telling us that the position vector A is equal to this and that of B is equal to this. And they are saying if C is a vector such that A dot C is equal to what? The magnitude of what? The position vector C. And magnitude of what? Position vector C minus what? A is equal to what? 2 times square root of what? 2. And the angle between A cross B and C is 30 degrees. So with this particular problem, it's kind of application, right? It's kind of application. But first of all, what we have to do is that we have to find our A cross B. That is the first step. So I'm going to guide you through. and I'll give you the final answer to arrive at it. So step 1, you have to find your A cross B. So A cross B first. And you know that A cross B can be obtained very easily, right? So we have your A here to be 2, 1, 2, and your B is this 1, 1, 0. Okay, so if you want to obtain your A cross B, then you're going to have 1, 1, 2, 0, J, 2, 1, 2, 0, plus K into 2, 1, 1, 1, right? So our A cross B will be equal to I into, this will give us 0. Then you have 2 here, minus J into, this will give us 0. Then we have 2 here, but there is a negative, right? Yeah, there is a negative, so it's going to be what? Positive. Positive times negative becomes, so we have negative affecting this, so plus K into, this will give us 2. 2 minus 1, then so we are going to have A cross B to be 2I minus 2J minus plus K, right? So that is what we have for A cross B. So we can also write this as 2 comma negative 2 1 in the angle bracket form. They are all the same. So if you see this and you don't see this, they are all the same. If you see this and you don't see this, they are all the same. This is called the angle bracket form, and this is the position vector form. We use this when we are in space, because we're going to see a lot of vectors there, right? That is why we use this when you are dealing with higher dimensions. Okay, so right after this, we have to use the triple product magnitude formula, right? So we know that from the question, we know that this is what we need, okay? So we have to obey this, right? We know A cross B, magnitude of that, dot cos theta, right? Cosine, right? This is cosine. So cosine sine theta. And we have been given the angle between these things to be what? 30 degrees. So we have our theta to be 30 degrees, right? So we are going to substitute that. So we know that when you find sine theta, which is sine 30 degrees, we're going to have 1 over 2. Sine 30 is half. Now, once you have that, then means that you're going to have this here is going to be A cross B cross C will be equal to A cross B dot C dot half, right? And you know that the magnitude of A cross B, we have to find the magnitude of A cross B. So A cross B, magnitude of that will be equal to square root of what we have here, 2 squared plus negative 2 squared plus 1 squared. So we have 4 plus 4 plus 1, and that will be 8 plus 1, which is 9. Okay, so the magnitude of A and B is what? 3. Square root of 9 is what? 3. Now we have the magnitude of A cross B, right? But it's attached to what? Magnitude of what? C times what? Half. Now, once we have that, then means that we are going to attach that to what? Magnitude of C dot half. So we're going to have magnitude of C over 2, right? So what we needed, we don't have the position vector for C. So we have to use some representations to represent the position vector what? C. So we are going to say that position vector C should be equal to X, Y, and Z. Okay? Because we were not given position vector C. So the best way to do is to use your own representation, that is X, Y, Z. Okay. So the question says that if C is a vector, so C here we have noticed C to what? A vector, such that A dot C is equal to what? The magnitude of what? C. So A dot C is equal to what? The magnitude of what? C. So the magnitude of C here is going to be 2x plus y minus 2z, right? And we know that this is, right? The A dot C is what? 2x plus y minus 2z, okay? And we have the position vector for C to be this. So its magnitude is what? Square root of x squared plus y squared plus what? Z squared. So we know that the magnitude of position vector C is this. So we consider this as equation 1. And then we say that position vector C minus A, the magnitude of that was given as square root of 2 times square root of what? 2. So once we have this information from the question, then we can go ahead and substitute that information here. So we are going to have square root of x minus 2 all squared plus y minus 1 all squared plus z plus 2 all squared to be equal to 2 times square root of what? 2. So from here, we have to square both sides, okay? So we have to square both sides to simplify terms. So we square both sides. So squaring both sides, we are going to have x minus 2 all squared plus y minus 1 all squared plus z plus 2 all squared equals 8. Square root of 2 times square root of 2 all squared is what? 8. Okay, because this will cancel this. We have 2. 2 times 4 is what? 8. Okay, so this is what we have. Okay, now we have to use the condition given in the question. We are told that the angle between A cross B and C is 30 degrees, okay, of which we did some analysis earlier. So we are going to substitute that information in here. So let's use the formula that the magnitude of this is equal to this times magnitude of this sine theta. This implies that A cross B cross C, the magnitude of that is equal to this times this times sine 30 degrees, right? And we know that this is equal to half times a cross b dot the magnitude of c. And we can just compute the magnitude of a cross b, right? As the magnitude of a cross b as square root of 2 squared plus negative 2 squared plus 1 squared. And that is basically square root of 9. We earlier on obtained this, right, as 3. So we're going to substitute here. So now we're going to have 3 on 2 times magnitude of what? C. So what we have to do next is we have to, try and use this knowledge that we have here. This is what we are having now, okay? So we have to find the value of the magnitude of what? C. That will satisfy this equation, okay? So it means we have to try the options, right? So we have to try the options that we were given, okay? And when we try these options, it means the only value that will fit for C will be what? 2. Looking at the options given, the only value that will fit for C is what? 2. If C is what? 2. So it means that when we find the magnitude of A cross B, A cross B cross C will be having what? 3. Are we okay? Because the only value that will satisfy here is what? 2 for C. So if C is 2, that means that we are going to have 3 over 2 times what? 2. And this will cancel this, so we have what? 3. So it means that the value of what? A cross B cross C is what? 3. So interesting, right? For this problem, it's very practical. So it means you have to watch and watch over to really understand it. So you can try and error, okay? Take the options, try, and see if C, when it takes C to be 1, is it going to work? When it takes C to be, let's say, 3 on 2, is it going to work? If it's not working, then it means that the best value of C that will fit into the model or into the equation is what? 2. So 2 will satisfy for all. So hence the value of the magnitude of A cross B cross C is 3. Very simple and interesting problem that we have on question number 18. Now let's take a very short break and come back to finish 19 and 20. Welcome back from the short break. We are going to finally finish the work, okay? This is question number 19, last but not the least. Okay, so with this, we want to find the cross product of two vectors a minus b and a plus b, right? So with this problem, we have to use certain identity, right? So we know that there is this identity that says that a minus b cross a plus b is equal to a cross a plus c cross b minus b cross a minus b cross a minus b cross what? B, right? But we know that when you expand this, this is what you have. basically. Okay, now we know that but A cross A is equal to what? 0, and B cross B is equal to what? 0. Okay, they are all having the position vectors. Okay, A cross A is equal to 0 and B cross B is equal to 0 as well. Now, one thing you have to know is that if A cross A is equal to 0 and B cross B is equal to 0, then these are all identity. Okay, then we can say that this and this, they have some, this and this have some common informations, right? So we can say that negative B cross A, negative B cross A is equal to negative into negative A cross what? B. So when you expand this back, you come back to this information, right? So that is equal to A cross B, because when you expand this negative will go and you have this. So you have A cross B, position vector A cross position vector what? B. So finally we can say that A minus B cross A plus B is equal to 2 times A cross B is equal to 2 times A cross what? B. Yeah. So this is an identity. Okay, you have to learn it. It's very important. When you have you want to find the cross product between of two vectors, let's say A minus B and A plus B, then means that A minus B cross A plus B is equal to what? A cross A plus what? C plus A cross what? A cross B minus B cross A minus B cross A minus B cross B, right? So this, if you do use binomial expansion, you get what? This. I don't have to be doing this at this point, right? So this is also an identity. A cross A is equal to what? 0. B cross B is what? 0. And you know that minus B cross A is the same as minus into minus A cross what? B. Because when you send this, you're going to have what? Minus B, and this will become what? Positive. So it means that this and this what? Are the same, of which is the same as this. So if this and this are here, then means that when you expand this, you're going to have what? 2 times A cross what? B. So that is question number 19. Now finally, we are going to look at the question number 20, the overall. Okay, so question number 20 is basically easy for everybody to try on his or her own, right? So I can give the final answer for you to try, or you say we should all do it. You let me give you 3 minutes. Time starts now. You can pause the video and try it out. Okay. Now, if you have a problem like this, and this is basically an optional options questions, right? They've basically provided the options and they're asking you that which of them is a unit vector along this position vector. Okay, so you know that if you want a unit vector, so let's say v, okay, you just have to find the magnitude of this, then use the result to divide what? This. So the magnitude of, let's say this is A, will be equal to 3j plus 4k, right? So this, you find the magnitude will be equal to what? This means that the I component is what? Empty, and that is 0. So we have 0 squared plus 3 squared plus 4 squared, and that is 9 plus what? 16. Okay, and 9 plus 16 is what? 25. Okay, so that means that the magnitude of position vector A is 5 units, or 5. Okay, now once you have the magnitude of the position vector, then you just have to divide it by what? The position vector, to have the unit vector. So unit vector for A is equal to this over this. So we have 3j plus 4k over 5. So this is the same as 3 over 5j plus 4 over 5k. Very cheap, right? I hope you had it. It's supposed to be 3 on 5j plus 4 on 5k. And that brings us to the end of the lesson. I am Inorganic Tutor, and I make sure that students understand complex concepts. And so, very soon we will begin with data analysis, how to code with ease and analyze very easily. Okay, so we have this teaching assistant who is very good and is going to take the course from the scratch. Okay, from the scratch, from the basics at all. So we will begin with R. You go to Minitab, you go to SPSS, to make sure that students equip themselves with some skills that at least when they graduate, okay, they can at least have some skill that if they are not getting a job, nowadays data analysis is a whole job on its own. So I want everybody to follow us on YouTube for this immense initiative. Until the next video, keep learning and stay inspired. Bye bye.